Okay, so we are going to go through this program. It allows people to input data of a student using this student structure we have here, and it includes the name, date of birth, registration number, the program code, which would be the course code, and then the tuition, and then a node. I mean a pointer. Now this pointer is pointing to the next node. So as you can see, we have maximum length, registration number length, and yes. So the purpose of these definitions we have here are to define how many characters we are to have within our given variables we have. So with this, we have prototypes we want to be able to use. So now we have the display menu, create student, insert student, and as you can see, there are many up to the swap and the export. So once we run our program, the first thing that you're going to see is we're going to call the student structure that we had above and make it a pointer. We point it to the head, and the head will be set to now. So from this, it will display the menu once it runs this display function. And with this, it will allow people to switch through the choices. And these choices include inserting student, displaying students, updating, and yes, once the person chooses something outside the range of the case, it will print out an invalid choice and ask the user to try again. So with this, the person, remember we are running the display menu, it will print out our menu in this format, and with that, the person will be able to choose. Now we have the function to create a student. And remember, using the student structure we have above, we shall have the student pointing to a new student, and the memory allocation will allow us to check whether there is memory for us to put our data that we are inputting. So with this, we shall set, once we run the program and we choose to insert a student, it will print out this and prompt users to write out the inputs, the things that they need to address. So with this, it will return a node, new student, once the person is done inputting all the data. So we have this insert student function. So it will grab the student head again, and you realize here they grab the information from the new student that we inputted from above. And once it is got from up there, it will return the new student and keep on printing it. So once the students' things have been inserted, this function will allow us to print it within the node, and thus it will add the student to the linked list. So from there, once someone is done adding all the students, we want to be able to display them. So when it comes to displaying the students, it will print out the list. Once they are inputs, it will print out them according to the heads. Now the heads are having the student object, and the student object has those attributes of the name, the date of birth that are under it, and that is what will be printed here. So in case there are no students within the linked list, it will print out that there are no students found. So with this, we want to be able to update a student's information. But realize that if there are no students within the linked list, then it will return there are no students found. Otherwise, it will ask the person to enter the registration number to update, and once the person places in the registration number, it will search through the linked list, and then it will return the person's registration number. So with this, the person will be able to check the information that is there and edit it according to their wish. With this, we want to be able to delete a student. And deleting a student, we shall use the registration number again. We are searching for students using registration numbers, and then we delete them. So with this, it will implement the code here. If the student to be deleted is the head, it will implement this code, and then it will print out the student is deleted successfully. If the student is not the head, it will search for the student using this while loop. If the student is not found, it will print this. And if the student is there, it will remove the student from the linked list. So we have the searching using the registration number. With this, a student will be searched for, and we are using the registration number as well. So once the registration number exists within the linked list we have, it will print out the student info. Once the student is not there, it will print out that the person is not found. So we have the sort function here. I want to allow people to be able to sort the linked list. You could say alphabetically using the name whatsoever. So with this, this code will be implemented, and once we have the lists, we'll be using these nodes, as you can see. But as it's working through this, it will be searching each node, checking if the arrangement that is requested for is, well, let me say it's ascending order, to check if the linked list in node A is greater than, or is supposed to come after the linked list in the second node that comes after A. So with that, this is supposed to be a function to allow to print out the sorted list once it's done sorting them. And you realize that we call the swap function that is here, the swap. So the swap function will get the student in node A and a student in node B, and then swap them. And once they swap them, they will be stored back into the linked list. Yes. And as you can see, they'll be gotten from the other side and be printed here. Okay, so now, lastly, we have the function to export the CSV files, and it will grab the students, place them into a folder. Now, this append function allows them to add. So in case there are no students, it will return this error. But in case there are students, it will print them, and then it will claim that the records have been exported successfully. Thank you.